Hey everybody, this is Larry. This is day 24th of the May Leetcode Daily Challenge. Let's hit the refresh button so we get the problem. Hit the like button, hit the subscribe button, and let me know what you think of this today's problem. How did you solve it? It's some sort of binary search tree, it seems like. Let's click on it. Uh, Construct binary search tree from preorder traversal. Return the root node of a binary search tree that matches the given preorder traversal. It is guaranteed that for the given test case, there is always possible to find a binary search tree of the given requirement. For example, you have this input, the output is just this. I guess this is a tree node, the root of the tree node with that in the form. Okay. Um, yeah, so the way to solve this is that given a preorder traversal, and that means, what does that mean, right? That means that, well, the first node that you order, that you process, if you want to call it that, the first node that you hit will be the root node that you always do, and then you kind of keep doing that, uh, bisecting the left and the right? And I think that's probably good enough to start, because given that it is pre-order, you go left and then go right. And that's always going to be the case that given a binary search tree, all the nodes on your left will be smaller than your current node. And then we can kind of do that recursively. And yeah, that should be good enough. So there is some caveats here in with respect to the running time. And it's 100, so it doesn't matter that much in this case. But it is something to consider. And there are a couple of ways to kind of think about it. And yeah, okay, let's start by writing the recursion, for me anyway. That's how I like to do it. Let's just say process this node. Let's just keep track of this node with an index. And here we can set node is equal to, or root is equal to none, and or something like that, and then return root. We might actually set this as equal to, yeah. Oh, and then let's just keep track of the parent from here. And here, what do we want, right? Well, if, just filling it out a little bit. And I'm just trying to think about now how to handle the root cases. It's not a big deal, but let's just do it recursively, and then we'll handle the root case because that's a little bit weird. But let's say we're processing pre-order sub-index. So now let's do it naively first, given that n is 100, and then we can think about ways to optimize it and so forth. So now, so when we process this, first we create a node, a new tree node with the value that's in the pre-order sub-index. Let's say no left, no right. So let's say current node is equal to this node, right? And then, actually, maybe we don't need the parent. I'm not sure. But yeah, but then now, let's just say then we can process of 0. That actually maybe is good enough. Just thinking through the edge cases and the base cases and so forth is useful, I think. But we might need, I think we need one more variable though. So now, given that this is the case, well, what's on your left, right? Let's say we have a left subtree is equal to process left, right? Like we don't know what it is yet, but that's fine. And then right process right. And then now, after that, we just have to set node is equal to the thing, node is equal to that thing, and then return node. And we're good, right? But what is the base case? What do we process this with? Well, let's start with something really, naive. And let's process from index left and then index right. Let's just actually convert this to left, right index. And then now it's just from 0 to n minus 1, because we want, for the purpose of this, we just do it inclusive. And n is equal to the length of pre-order list. And then now your base case is if left node is greater than you go to right, then you return none. Uh, well, is it? No, because we did it inclusive. So let's actually change it to and then. Let's make it exclusive. Um, and then now the left node is just this index plus 1. Oh, and this is left. And the thing on your right side would just be the current left, right? Because node is the current left. This is the middle. Uh, so then just left. Oops. Oh wait, no, this is not right. But so now we have some mid, right? And then node dot right is also some mid, two all the way to uh, the right. So basically, now you're dividing the pre-order list into two components, left and the right. So let's say again here, we're trying to find the left with all the numbers on the left, and then we do a recursion, and the right is all the numbers that are bigger than 8, and then you do recursion, right? So now we have to find mid. How do we find mid? Well, there are a couple of ways to do it. Obviously, you could do a linear search. You could have done. You could also do what you might call it. You could also do binary search, and linear search will mean that this algorithm is n squared because in a degenerate case of a linked list, it'll be n squared. And with binary search, it'll be n log n because at most you have n or log n operation on each level on that linked list, and then you could do it that way. But is the so those are the two ways to go about it. In this case, it doesn't really matter because n is equal to 100. And maybe the other way to think about it also is like the max element that we process, right? Um, yeah, and I think that should be good enough to get started. And maybe right doesn't have to be a right. It's just hmm. I think there's also another way to think about it, which is what I'm trying to think about, where you can get this down to O of n, being that maybe you could only look at each node once, and then that's it, right? But right now we don't have that. Um, and we can do that if we magically have. No, I mean, okay. I think I'm just going to do the linear search, and because binary search is also trivial, so definitely practice that. But let's just say for mid, oh sorry, yeah, let's see, mid is equal to left. While is there? Now I'm just looking up to see if they're distinct. They are distinct, so we don't have to worry about how to handle the cases where they're equal elements. But while pre-order of mid is, let's see. So we want mid such that we want to find a mid such that um, such that this number bisects it, right? So we just have to find. Yeah, so we just have to find the first number that's bigger than this number, and then that will be your mid, because this is inclusive and this is exclusive, right? Okay, so let's find the first number that's bigger than this number, and then we can break. Uh, and mid is less than right, say, because if it's equal to right, then that's fine as well. But yeah, oh, and this is not. Is this right? Because this is always going to be true. So actually, we want this. Right? Whoops. Um, but yeah, that's let's run it real quick. Ooh, maximum recursion happened. Uh, hmm. Why is this part? Did I misunderstand how to create this? Oh, process mid left. Okay. Oh, sorry, mid right. But that should be equals to right, right? And when that is odd, maybe. Oh, this is we want to get the first element, so I got the signs wrong. Whoops. First element when it's bigger than that. So yeah, okay, it's still wrong, but we want to get the. Oh wait, no, this should start out smaller than left, and then we want to get first element bigger than that. Okay, so that sign was right. Definitely. Sometimes you do get off by ones, and that's what happens. Definitely don't want mid. We want mid to the first element, so this should be right. But let's just print out left, right. Maybe I have some base case wrong. Real quick. Uh, 06. So, I mean, that's fine, but that shouldn't be the first case. Did I? So left is equal to, no, this is not the issue. So, and mid is equal to, oh, what the, whoops, why did I have a break in here? I think I was trying to do another thing, but now that was just more silly. Apparently I have a lot of issues. So let's take a look. Let's put it first so that it goes before the recursion. But a lot of silly mistakes seems like. If this is 06, 06 goes to what mid is. How is mid 0? Well, this is. And again, I think I signed wrong again. Because it starts off being 0, and then we wanted to break on the first one. Okay. Clearly, really bad at the signs right now. But also, wow, a lot of lines. Um, hmm. Preorder of left. And mid is equal to 0. Why does this not happen? Oh, of course this never happens because this always is going to be false because it is itself. Okay. Still silly mistakes, but that's fine. And then now we have to check. We have to do this first because we're doing the +1. Before it didn't really matter. Cool. So yeah, so silly mistakes aside, sorry, I mean, for this problem solving, I'm a little distracted uh, because there are a lot of sirens outside and there's a protest outside. And when you do competitive programming or interview, make sure that you're in a place where you're able to focus and find peace, so that you operate optimally. Otherwise, you just get a little bit distracted. But in either case, yeah, so this looks good. The only thing that we have concerns about is the running time, because this can take all of n time. So then, and for each node, this could be n squares, we said. So we could actually fix this with using binary search. And you can do that as practice. But I'm going to just submit it right now just to kind of see, because if that is wrong, and that's a little embarrassing. And there's actually a linear time algorithm to solve this if you keep track of uh, the root node, and then kind of keep track of the things that go into left and right as you go. Because yeah, I think that's right. Because as you process elements, you you do a recursion, and then you just basically look at one node at a time with the recursive stack. Um, and then pop up the stack as soon as you see a number bigger and so forth. But Anyway, but I'll leave that implementation for you to experiment with. Today, I'm not gonna lie, this video is not as great as it should be because like I said, I'm a little distracted. But given that on an interview, I would expect at least to come up with the n log n solution with the binary search, because binary search is important. The recursion is important as well, and also just constructing from a pre-order traversal is pretty standard in either case, and there are a number of ways to do it. Hope you enjoyed the video. But yeah, for competitive programming, I would definitely just did what I did, because the first thing I would notice is like n is equals to 100, so I don't have to be really that I don't really have to be that performant. I just have to get it done, and I would try to get it done as soon as possible, even if I have some silly misunderstandings on my part or with respect to off by once. But otherwise, yeah, a cube problem definitely worth the practice. Let me know what you did. Did you figure out the linear solution? Did you have a linear solution? Did you do it n square, n log n? Let me know how you did, how you feel about this problem, and I will see y'all tomorrow. Bye bye.